And next one is Bibi. Haven't seen you for a while.
Wow, look at that picture. So pretentious. All right. Let me just get set up here. One sec, guys. Did you guys clap for my entrance? I need support. Thank you. Thank you. Jeez, guys, it's pretty nerve-wracking being up here. Okay, hang on a second. Let me just get my stuff connected. Let's pray that it works. Okay, not that one. All right, here it is. Cool. Who was here last event? Okay, so you guys know everything about Interledger, right? Anybody remember what I talked about last time? Yes? So what did I talk about last time? I'm not gonna put you on the spot. I'm joking. Cool, so if you guys remember, last time I was here, I was telling you about this whole stack that we have, right? Like this hourglass shaped thing with a bunch of like little building blocks. And I was telling you guys about the first and the second. Does anybody remember the very first one? The first block? Huh? I heard someone whisper and it sounded right. Okay, anyways, web monetization. The second block, anybody remembers the second block? That one's a tricky one. Open payments. That's right. Okay, you were right. I knew you were right. Cool, so as promised, I am back and I am going to talk to you guys about the rest of the stack today. It is a lot to cover, so I'm going to move a little bit quicker than usual than I did last time because my presentation took about like almost 30 minutes. Before I dive in, I do want to mention that we're also hiring, and I didn't raise my hand earlier just because I do have this slide up here. I know some of you guys already have applied for this role. We do have, I think, 2 or 3 engineering roles open. So if you are looking for work and you're passionate about open source, you're passionate about payments, making sure people have access to all of these systems across the world, then Interledger is the place for you. So I'm leaving the QR code here. This redirects you to a LinkedIn post by our HR director. She's the point of contact, but of course, if you want a referral or you want to talk to me about Interledger, you want to learn more, what are we up to, what are we doing, what are we about, feel free to reach out to me and I'm super happy to answer your questions. For this role specifically, we are looking for mid and senior level backend engineers. Golang specialty is preferred, but I know there's also a few others that are more focused on just the JS stack. Cool. So I'm gonna get started and we'll dive right in with an image of what the Interledger stack looks like today. So we have this hourglass structure, like I mentioned, and it's composed of all of these different layers. And we're going to be talking about each and every layer today. I'm gonna go through them one by one, so let me not confuse you guys right now. However, I'm showing you this because some of you might think this looks familiar. Does this look familiar to anyone? Yeah? I thought I saw a hand. No? It doesn't look familiar at all? Does anybody know how the internet works? Bingo. So, I was hoping you guys would say, yes, this looks very familiar. I've seen this before. So thanks, Andre. So, the internet also has building blocks. I'm not gonna go too deep into the internet bit because, of course, that's a little bit out of scope of this presentation. But what I do want to mention is this is not a coincidence because the Interledger protocol was modeled after the Internet protocol. So the only layer that doesn't really have a equivalent is the very bottom layer. And you'll see that the bottom layer is a bit disconnected from the hourglass on both sides. And what that means is that those 2 layers, they are not defined by the stack. and they don't affect the stack either. So that's why they're a bit disconnected, but they also have to be there so that the hourglass makes sense. So in our case, the bottom layer, it's the settlement layer in the Interledger protocol, and the physical layer in the internet stack, they are both extrinsic. So like I mentioned, they don't affect the stack, they are extrinsic. Every layer on top of each layer is a standard that can be implemented. And just like the internet, Interledger is also a network of connector nodes, which sends a bunch of packets. However, while the internet is only concerned with packets of data, Interledger is concerned with packets of currency. Is that making any sense? Am I speaking Greek? Making a little bit of sense? Okay. All right, I'm gonna slow down. So when there's currency, when there is movement of money, can anyone guess what else is involved when you're sending money to connectors? Can anyone guess? No. Conversion, currency conversion. So think about it this way. Instead of just forwarding the packets, which is what the connectors in the internet do, Interledger connectors also facilitate the currency exchange. And we're going to talk a little bit about that in a second. So hopefully that's making sense right now, at least high level. Okay, let's take a look at the individual layers, because I think if we go block by block, this will help us build the understanding of the overall protocol as a whole. Sound good? I didn't hear you guys. Sounds good? Yes. That's a little bit better. Cool. So, like I said, the settlement layer is not really a part of the stack, but it is required for the protocols on top of it to make sense. So I have a few examples here, such as fiat, crypto, and mobile money. Let's talk a little bit more about this. So the settlement can really happen with any kind of value. The most straightforward example would be US dollars, pesos, Canadian dollars, you name it. However, there's other types of money. Does anybody know mobile money? Has anybody heard of it? Yeah?
Yeah, it's like people.
So it's kind of like, yeah, it's like using your phone to send value. I never knew about this concept. Yeah, so I never heard of this concept until I started working for Interledger, but mobile money is a thing in African countries, I believe. Instead of dealing with money, it's like mobile money. And I was like, wow, that's interesting. So in the end, what I'm trying to say here is we can settle with anything of value. It depends on the peers to agree on what to exchange. So those little connector nodes that we saw, they say, hey, I'm going to send you chocolate. Do you accept chocolate? And then the other peering node might say, yeah, I take chocolate. Let's do it. So we can shake hands and exchange chocolate. Is that making a little bit more sense?
So we just invented the gold standard.
Hold on to that thought. Hold on to that thought. Okay, so let me continue. So that was the very first settlement layer. Now, I want to talk about the link layer, which is the next up on the stack. So the link layer basically defines how the peer connectors communicate. So let's take a look at that. As of today, there's only two protocols that can serve as the link between peers, and that's BTP, which stands for Bilateral Transport Protocol, basically defining WebSocket-based communication. The second one is ILP over HTTP, which is HTTP-based communication protocol. Pretty straightforward. Okay, I'm moving pretty fast. Are you guys keeping up with this? Okay, I see some thumbs up. Cool. Next up, now we're about to get a little juicier. So this is the actual Interledger protocol. let's take a look at this. So right now, we are on version 4 of the protocol's implementation. And the Interledger protocol essentially defines the protocol for sending packets of money across different payment networks or ledgers. So let's take Alice here on the left and Bob on the right. So Alice only has Bitcoin, but Bob only wants to receive US dollars. Luckily, there's a connector in the middle that accepts Bitcoin and then converts it into USD and forwards it to Bob. But sometimes it's not that straightforward. Maybe there's not just one connector that connects Alice to Bob. Maybe there's multiple hops in between, and the packet could actually take several routes to go from A to B, even within a single payment. And I'm going to talk about payment splitting in a second. But it all depends on the risk appetite of the nodes. And I'll circle back to this word in a second. But depending on how your payment is split, some packets could actually take the upper route, and some packets could take the bottom route. It just really depends. So, why does the system only depend on the risk appetite of the middle nodes? Why do you guys think that is? Any takers?
Currency exchange over time.
Yeah, that's a good, yeah. Yeah, really good. Okay, cool. Hold on to that thought. So, if we had optimistic payment execution, it would look something like this, right? Every node returns a positive, hey, pretty good, yeah, send it, yeah, this is good, send it. However, it's not always like that. Alice's nodes forwards to the second node, and then the second node to the third, and so on in this optimistic execution, right? It just always circles back with a green light. But what happens if the last node fails? The very last node fails, but the money already left Alice's wallet, but it never made it to Bob's wallet. Then what? It wasn't Alice's fault, and it wasn't Bob's fault either. So what do you do then? In that case, the optimistic execution doesn't quite work very well, right? So in order to move the transaction risk from Alice and Bob to the middle nodes, we use a two-phased transfer. First, we prepare the packets. First, prepare the packets are sent through the network from Alice to Bob, just the prepare packets, okay? There's no money right now. We're just preparing the packets. Then we fulfill. So what happens with the fulfill? Sorry, guys. It's really difficult for me to concentrate if there's too much noise. Thank you. So if Bob is satisfied with the conditions of the transfer, so all of those little hops, we're gathering data for the prepare. So if all of the nodes get to Bob, and then Bob's node is happy with the conditions of the transfer, then Bob will actually fulfill the transaction. So that way, it's on the peering middle nodes to adhere to the peering agreements for the successful payment to go through later. If one route proves to be unreliant, then a different route can be chosen, and then all the packets will take that route instead. So hopefully that's making a little bit more sense now, how in that map, all of those little nodes connect and then agree, and then the transaction happens. Are you guys still with me? Did I lose anybody? Yeah? Okay. All right. Cool. So I've been talking about the transfer conditions here. Let's take a look at what exactly is stored in the little packets. So the Interledger protocol sends ILP packets. We call it ILP packets. So each packet has a destination, which is an ILP address. it looks very similar to a URL. I'll point that out, but I'll leave it at that. Next, we have an amount. Note that there's no information about the currency because the two peered connectors have agreed upon a peering currency or asset beforehand. Because remember, we can send something that's not money. We can send an asset as well. So you may also be wondering why the amount over there is so large. The reason for that is that we can only express numbers in integers, and the asset scale has also been agreed upon. Oh, oops, no, that's the wrong one, sorry. That was the wrong note there. Anyways, yeah, sorry. So the expiration date and time, those are pretty straightforward, but again, if we only want to fulfill a transfer within a certain time limit, and that time has expired, then the transfer will no longer occur, even if all of the agreements return a green light. But finally, we can also put data inside of an ILP packet, just like a JSON string. So let me move on. As promised, here are the ILP addresses. So earlier I pointed out that this can look very similar to a URL, and I want to talk a little bit about the this in a second here. It's my next slide, but right this second, I just want to talk about the format. So ILP addresses, they follow a very specific format. First, we have the allocation. So in this case, test for test network and G for global live network. Next, we have the neighborhood, and that can be something like a company name or an institution, followed by the account identifier. In this case, from earlier, it would be Alice, but it could be anything. It could be Scotiabank. And finally, the interaction. So that last little string over there, that's called the interaction. And every new request could encode some business logic into that interaction over there. So we'll talk about that in a second. So this is what I wanted to get at earlier. How do I request an ILP address? So this is where payment pointers come into play. They are human-readable payment identifiers that resolve to a URL. So very interesting. The URL then points to an ILP address. So they always start with a $sign. So you'll note that it always starts with a $sign. And in this example specifically, it's $wallet.com/Alice resolving to https wallet.com Alice, but it points to test wallet Alice and some interaction over there. In the case you want the root domain to also serve as a payment pointer, it will resolve to the domain, in this case, wellknown/pay, the one in blue right there. And it can also point to a ILP address. So I think I'm getting very technical here. Did I lose anybody in this one? No? I feel like that's a maybe, but I will be talking to you guys in a second. Hold on to your questions. Okay, let's move on to the transport layer. So for the transport layer, we currently only support one protocol there, the stream protocol. So stream stands for streaming transport for the real-time exchange of assets and messages. That's a very long acronym. They tried really hard on that one. But anyways, the stream is a protocol that allows us to stream data and money over Interledger. It can also split larger payment amounts into smaller packet amounts, like I alluded to earlier. And it also makes sure that all the packets at the destination are recombined into that larger payment. So it basically implements the concept of penny switching. But there is more. With stream, we can have multiple logical streams over a single connection. And these logical streams can transport money or data, and they can also be bidirectional. Okay, finally, we reach the top layer of the Interledger stack, the application layer. I talked a little bit about open payments last time I was here, but I don't think I went into too much detail, so I'm gonna quickly go over this again. But currently, for the application layer, we support two protocols, SPSP and open payments. So I don't think I spoke about SPSP last time, but it stands for Simple Payment Setup Protocol, and it basically just defines what needs to be returned when a request is made to a URL that belongs to a payment pointer. So for example, if I send a GET request to an URL that belongs to a payment pointer, in that case from earlier, the well-known /pay, the returned object should implement the following: the destination account. So if you guys just take a look at that object below. So destination account, which is an ILP address, a shared secret to encrypt the stream data, and the flag describing whether the stream receipts should be enabled. But I'm not going to talk about receipts because we don't really use them at this point. Yeah, we don't really use that at that point. And then open payments. Now, open payments is the more interesting of the two application layer protocols. It is an API standard for account servicing entities that allows third parties to securely access digital wallets for viewing account information and initiating payments. So let me walk you through an example to explain its components. Oh, I guess I removed the example. So the very last layer, if you guys remember, is the web monetization and the very top. I did talk about this at length last time, so I'm not going to. If you guys have questions about web monetization, come talk to me later. But very briefly, this API allows websites to automatically and passively receive payments from web monetized visitors. Do you guys remember that from my last presentation? I see heads nodding. Cool. So I know I've been talking a lot. I'm gonna just rapid fire the next few slides as an example of web monetization for those who weren't here. Actually, who was not here? Ooh, okay, cool. So I'm gonna very quickly go through an example of web monetization so you can understand what actually happens. You're gonna have to hold that question for later. I'm on time here. So let me give you one quick example. Let's take Music Plays. I don't think I used this example last time, but yeah. So Music Plays is a web-based streaming service. Think Spotify. Alice is the streamer and wants to pay using web monetization. And Bob is the copyright owner. So Bob put up a song on Spotify and Alice wants to listen to it. Now, Bob adds his song to Music Plays. He provides his wallet address to be paid when somebody streams the song. Alice enables web monetization in her browser. If you guys remember, we have an extension, yeah. She provides her wallet address to connect to the browser. Sorry, to connect the browser to her wallet. The browser then requests a grant to create a quote and a recurring outgoing payment on Alice's account. And the recurring word is very important here because you don't want to stop the song halfway, right? Okay, Alice's wallet provider asks her to approve the grant for the recurring outgoing payment. Once the grant is granted, web monetization is set up. So now Alice lands on Bob's song. The browser detects Bob's wallet address. The browser then requests a grant to create an incoming payment on Bob's account. So this is how Bob gets paid. Then the browser creates an incoming payment on Bob's account at his bank. And finally, after all of these steps, Alice can finally press play and listen to Bob's song. Cool. Like I mentioned, the recurring bit. So the browser periodically creates an outgoing payment on Alice's account, so she can stream however many songs she wants forever, and Bob keeps getting paid. Cool. Oh, are my slides stuck? Cool. Thanks, everybody. I hope you guys enjoyed this. This was the full Interledger protocol. If you guys have questions or you want to join the company or you're just curious and want to contribute, we are fully open source. So all of our code is on the web. If you're enthusiastic about contributing and you want to change the world, that's a tall order, hey. Feel free to come talk to me. And I would love to onboard you guys into our open source ecosystem. Thank you very much.
Thank you, Bibi.